the merging and diverging parts of freeways. Now we'll cover another type of part which is called the weaving segment. So what is a weaving segment? Like the previous parts, this one also has ramps, but now we have two ramps. Okay, and these ramps are connected to each other, and one of them is an on ramp, the other one is an off ramp. So these ramps basically then act as a U-turn, okay, on the freeway. So as you can see in the figure over here, you can come in from this ramp, go to the freeway, or you can continue onto the next ramp and go off the freeway like a U-turn. So the flow and level of service on these type of segments depend upon the number of lane changes. Okay, so you can imagine that people are entering and exiting both, and you can see the blue line and the red line which are indicating the lane changes to enter the highway and to exit the highway, plus we have the lane changes which are for ramp to ramp. So there are at least three types of lane changes happening, or at least two types of lane changes happening in this short segment. So that's why they become different and they become more complicated. So the number of lane changes is the main factor here, and then we also look at how many lanes are available to make the lane changes and how much is the length between the two ramps, and this length is called an auxiliary lane. Okay, so remember these two ramps are connected to each other. You can see there's a lane direct from the entry lane to the exit lane. Okay, so this one is called an auxiliary lane, and we are talking about the distance for this auxiliary lane, or simply the distance between the two lanes. Okay, so there are three important and unique factors here. First of all, how many lane changes are happening, and usually they are more than any other type of segment, and how many lanes are available to make these lane changes, and how much distance is available to make these lane changes between the two lanes, between the two ramps. And the extra lane which is connecting the two lanes, two ramps, is called as auxiliary lane. Okay, so just to show you an illustration of how the lane changes are happening, you can see it happens like this. You can see so many cars, they are moving together and they are going in different directions. Okay, and you can see it happens very fast, and I've already given you the illustration for only these cars. Okay, they are like, how many? They are 5 cars, but you know, on the real freeway there will be hundreds of cars, and all these cars will be doing something like this, going in different directions. So you can imagine how many lane changes will be happening at a time. One real example for this one is near Adhari Park. Okay, on which highway is this? Sheikh Isa bin Salman, I believe. Okay, near Adhari Park. When you are taking the exit towards Isa Town. Okay, so this one has this one is actually more complicated than the one I'm showing you. But when you take the exit towards Isa Town, on the bridge, okay, when you have already taken the exit towards Isa Town, you will see these two ramps with an auxiliary lane and so on and so forth. Okay, so this is a real example of a weaving segment which is in Bahrain. Okay, so I'm talking about this side which is going towards Isa Town. Okay, so the methodology, it follows 6 steps. The first step is the input data, which should contain volume as well, some of the other characteristics. Then we need the geometric characteristics of the segment, number of lanes, lane width, and the distance, and so on. Then we have to find out the minimum weaving length. Okay, so if the ramps are connected by a short distance, then this will be acting as a weaving segment. But if the distance between the two ramps, okay, these two ramps is very long, then one ramp will not affect the other one, okay, because of the high distance. So in that case, we will not consider it as a weaving segment, we will consider it as a this one as a merge segment and this one as a diverge segment. So it will be divided into two different segments then. So we need to find out how much is that length under which it will be called the weaving segment. Okay, then we have to perform the capacity checks like we did for the merge and diverge segment, if you remember, and then we find out the lane changes per mile, and then speed, density, level of service like we did for the previous segments. So the input data which we need is number of lanes including the auxiliary lane, the distance between the two ramps which is called as a short length, and it is from gore point to gore point. What is the gore point? I told you earlier as well. This one is called as a gore point. Okay, the meeting of the ramp with the freeway. Okay, so distance is measured from the gore point to the gore point. Location of the ramps. The ramps can be on the right hand side of the direction or the left hand side of the direction. So then we find out number of lane changes required. Okay, required will come from the geometry. Okay, I will show you how. So number of lane changes required to go from ramp to freeway, to go from freeway to ramp, and to go from ramp to ramp. Okay, and then we have the lanes which are given for weaving. Okay, what are weaving lanes? The lanes from which you go from ramp to freeway and freeway to ramp with 0 or 1 lane change. The lane from which you can go from ramp to freeway or freeway to ramp with 0 or 1 lane change. Okay, for example, if you look at the shaded area, okay, the lanes in the shaded area, they are basically the weaving lanes. So if I'm on the freeway, if I want to go through the ramp, I can do it with 1 lane change here, okay, like the red line. If I'm on the ramp, I'm coming onto the freeway, I can do it with 1 lane change like the blue line. Okay, if you look at the other lanes, if I'm in this lane, I want to go to the ramp, I have to make more than 1 lane change. So this one cannot be a weaving lane. Same thing here. Okay, so the weaving lanes are those lanes from which you can go from ramp to freeway or freeway to ramp with 0 or 1 lane change. Now there is no example here of 0 lane change. You have to at least make 1 lane change. Okay, if you make 0 lane changes, you will continue on the freeway. Okay, or if you make 0 lane change here, you will continue on the ramp. Okay, so we only have 2 lanes, weaving lanes, from which we have to at least make 1 lane change. Okay, for ramp or the freeway. Okay, so you have to find out this, then you have to find out interchange density, which is interchanges per mile. Okay, we already did that for the freeway segments. We have to find out the terrain type, capacity of the basic segment. We have an equation for that, we have already seen it. And you have to find out the hourly demand volume and the parameters which are associated with the volume, such as percentage of heavy vehicles and peak hour factor. Okay, so these are called the associated parameters for the volume. Okay, then when the process starts, you find out minimum lane changes. Okay, number of lane changes which are minimum. So lane changes of ramp to freeway, like how many lanes you have to change to go from ramp to freeway, multiplied by the flow which is going from ramp to freeway, and the same thing for freeway to ramp as well. Okay, so RF is ramp to freeway and FR is freeway to ramp. So lane changes required multiplied by the flow. Okay, so we are calculating total lane changes here per hour. So the flow from freeway to ramp, in this case, multiplied by one lane, because I have to make one lane change here. And the flow which is coming from the ramp on the freeway, again multiply by 1 because I have to make one lane change. Okay, so one for the ramp to freeway, the other one for the freeway to ramp. Okay, so you have total 2 lanes here. Now this one is slightly different, you can see here. Okay, so this is my auxiliary lane, but the other ramp has 2 lanes. Okay, so I can come from the freeway and go to the ramp with 0 lane change here. I can come from the freeway and go to the ramp with 1 lane change here from this one. Okay, the third one. So this one is also in my weaving lanes. Okay, because I can go to the ramp with 1 lane change. Okay, so I can okay, so basically this one is a weaving lane and this one is also a weaving lane. Okay, and for the for this one there is no weaving lane here. Okay, there is no lane which I can consider as a weaving lane, because if I am in the auxiliary lane, I want to go to the freeway, I have to make 2 lane changes. You can see the blue line over here. Okay, so the lane which needs 2 lane changes to go to the other side is not counted in weaving lanes. So yes, for ramp to freeway you have to make 2 lane changes, but this lane will not be considered part of the weaving lanes. Okay, so weaving lanes are these two. Okay, the top shaded lanes are weaving lanes. Okay, the bottom one requires 2 lane changes to go to the freeway. So I will put lane changes ramp to freeway 2 here, but number of weaving lanes will remain these 2 only, not this third one. Okay, so is this thing clear? Yes, anybody has any questions? Okay, so just an explanation why we will have 2 lanes here. This could be because the flow coming from the ramp is very low, but the flow going from the freeway to the other ramp is very high. Okay, so that's why. So in both these cases, the first 2 cases, the ramps were on the right hand side. The lanes were changing, but the ramps were on the right hand side. This is another configuration here where the lanes are in the opposite sides. So entry is on one side, exit on the other side. Okay, so you can see it here. So we have in this case the number of lane changes. So we called it two-sided weaving. Okay, two-sided weaving. Both of them are one-sided weaving. We have two-sided weaving, and the number of lane changes are basically for ramp to ramp. Okay, so you have this one, you can go from freeway to ramp like this. You have this one, you can go from ramp to freeway like this. Okay, so you need 0 lane changes here basically for both of them. Okay, so the entry and exit is not my problem. The entry and exit do not require lane change. Okay, so for two-sided weaving we only consider the lane changes for ramp to ramp. Okay, this one or this one. Okay, so this one is not counted, this one is not counted. Okay, so you have can someone tell me for this two-sided weaving case, the first one, how many weaving lanes we have for this one? How many weaving lanes we have? NWL, the lane from which you can go from freeway to ramp or ramp to freeway with 0 and 1 lane change. How many are there in this case? Yeah, 2. Okay, and in this case, okay, you have one here. Okay, you have this one here as well. Okay, so you can go from freeway to ramp from this lane, so 2 here. Then you can go from ramp to freeway with this lane, 0 lane change, this one 0 lane change, and you can go from, yes, okay, so you have 2 here and 2 here, so there are 4 here. Okay, this one, so we are talking about minimum lane changes. Okay, so if you are on the freeway and you want to come on the ramp, you can do it directly here, and same thing here, so 2 here, and this one, yeah, 2 here, and you have 2 here as well for freeway to ramp. Okay, so in this case it will be 4. Okay, then you find out the minimum weaving length. So this is called Lmax, is the minimum weaving length. If your weaving distance, the distance between the two ramps, is less than or equal to Lmax, then it's a weaving segment. Otherwise you will divide into two segments. One will be merging, the other one will be diverging. Okay, so the rest of the calculations will not apply to that segment then. Okay, so this is how you calculate Lmax. Weaving lanes I already explained to you. VR is this ratio. Weaving volume upon on total volume. Weaving upon total. What is weaving? The people who go from ramp to freeway or freeway to ramp. This is for one-sided weaving. One-sided weaving. One-sided weaving. These two cases. So what is considered the weaving flow rate? The one which is going from ramp to freeway or freeway to ramp. Okay, for one-sided weaving. If it is two-sided weaving, then ramp to ramp. Okay, I will replace this with ramp to ramp. Okay, so you have to see whether you have one-sided weaving or two-sided weaving. Okay, so this is for one-sided weaving. For two-sided weaving, you will only have ramp to ramp here. Okay, upon total. So this is your VR. Yeah, and I will told you if Lmax is if Lmax is bigger than your length between the two ramps, we'll consider the weaving segment. Otherwise, you will consider it as a basic segment in the middle, and then you have merge and diverge segments. Okay, then we can calculate the capacity of the weaving segment under ideal conditions. Okay, so this is capacity. So this is capacity of the weaving segment under capacity of the freeway segment under ideal conditions. CIFL, capacity of weaving segment. Sorry, no, not weaving segment. Sorry, this one is capacity of basic freeway segment under ideal conditions. This one is capacity of weaving segment under ideal conditions. Okay, so this is for basic freeway and this is for weaving segment. Okay, so for weaving segment, this is the equation. For freeway, we already seen the equation. Okay, we already seen the equation for CIFL. Okay, so now these values are per lane. These values are per lane. Once you calculate these values per lane, you will multiply with the number of lanes. Okay, for the whole segment. Okay, the lanes include all the lanes, including the auxiliary lane as well. So in this case I have 1 2 3 4 lanes. In this case I have 1 2 3 4 lanes. Okay, in this case I have 1 2 3 lanes. In this case I have 1 2 3 4 5 lanes. Okay, so you multiply the capacity with all the lanes. Okay, not weaving or non-weaving, multiply with all the lanes. Okay, once you calculate the capacity for all the lanes, Okay, so you calculate here per lane, then multiply by the number of lanes, and whatever number you get, it should be uh, you know it should be less than uh, these values. Okay, and the capacity is, as we have seen earlier, is number of passenger cars per hour. Okay, number of passenger cars per hour. One thing which I missed here, yeah, the maximum weaving length can also be taken from this graph as well, using only VR. You put VR here, you have to know how many weaving lanes you have. If you have two, then you will look at the solid line. So go from VR up to the solid line. This will give you the Lmax value. Okay, so there's a graph as well. Okay, so I was saying that your capacity across all the lanes should be less than these values. Okay, if it is more, then you will take these values and drop the calculated value. Okay, so let's say the calculated value is 2400. Okay, and you have two weaving lanes, so 2400 upon VR, and this gives you 2050. Okay, to 2400 will be dropped and 2050 will be taken. Okay, so your capacity should not be more than the value from this ratio. Okay, and so on and so forth. Okay, at this stage, once you know the capacity, okay, once you know the capacity, then you can compare the capacity with your flow rate as well. Okay, compare the capacity with the total flow rate. If the total flow rate is higher than the capacity, that means your level of service is what? If capacity is more than, oh, sorry, capacity is less than the total flow rate, what is your level of service? Yes, tell me. If demand flow rate is higher and capacity is lower, what is the level of service? Demand is more than capacity. So what's the level of service we have? We did it in the previous examples as well. If the demand is more than capacity, what level of service you have? Yes, the level of service will be F. Now what are the others doing? Sleeping? Ali, Dana, Zainab, what are you guys doing? Simple question, you should answer that. Okay, then we calculate lane changes per mile. We call it lane changing rate. So lane changes are of three types. We have required lane changes. Okay, so these are the lane changes you have to make. Okay, then we have the optional lane changes, which are because of misposition of the vehicle, and we have optional lane changes for non-weaving vehicles. Okay, so we have one which is required for the weaving vehicles, which are going from ramp to freeway or freeway to ramp. Then we have for the same vehicles but optional lane changes. So somebody was going to the ramp, but he was in this lane for some reason. So now this guy has to make three more lane changes. Okay, if he was in the right lane, he would have only made one lane change. But since he was in the wrong lane, not like wrong, like, okay, he is in the same direction, but he is not in the closest lane to his ramp. So he is making extra lane changes here. So he is still part of the weaving volume. Okay, he is still part of the weaving volume, but he was not in the correct lane, the lane in which he should be. So he or she will make extra lane changes. Okay, but uh, we can see that anybody who is even the closest lane to the ramp still has to make one lane change. And same thing with this guy as well, the guy who's coming from the ramp. If he makes one lane change, he's on the freeway. Now he can stay here, but he may think that no, let me go towards the next lane or the extreme left lane just to go faster. So these are optional lane changes. The next two are optional lane changes. Okay, so these are the optional lane changes, and then we have the optional lane changes for non-weaving people. For example, somebody is just on the freeway and he's continuing, but this guy can still decide that I don't want to be in the middle lane, I want to go to the extreme left. So this is an optional lane change for the non-weaving person. Okay, and somebody may want to go from ramp to ramp, so he can go from ramp to ramp just by this lane. He doesn't need a lane change here, but he decides let me go to the other lane and then come back to this lane. So this is an optional one for non-weaving people. Okay, people who are going from ramp to ramp or freeway to freeway. Okay, and on this side then it will be the other way around. Okay, the required will be for ramp to ramp people, and the weaving will become ramp to ramp, and the non-weaving is basically freeway to ramp or ramp to freeway. Okay, but the idea is same. People who are required to make lane changes, they are weaving. People who are weaving but they are making lane changes just because they are not in the correct lane, and then people who are not weaving but they still make the lane change. Okay, non-weaving people, they don't need a lane change at all. Okay, but they are still making it, so they are creating some extra turbulence, and we have to consider all these three types of lane changes. Now I've already given you one equation for lane changes, which is this one. So these are minimum ones. These are required for weaving people, required lane changes for weaving people. Okay, and then we are left with two others, optional by weaving and optional by non-weaving. So this one gives you, this part gives you optional by non-weaving people, optional lane changes by non-weaving people. Okay, so we need the short length, the length between the two ramps, we need the number of lanes total. Okay, and we need the interchange density. Interchanges, you count how many interchanges you have. The interchange is the point where two highways are crossing each other. And we are talking about a freeway, so it's not an intersection, it's an interchange. So you count it, and like I mentioned for the freeways as well, you count it for 3 miles forward and 3 miles back. So you are on your segment, you count how many interchanges you have, and you move 3 miles forward, and then you go and count it for 3 miles back as well. So your total is 6 miles. Your total is 6 miles. So whatever number of interchanges you counted, we divide by 6. So this, after the division, you will get interchange density, ID. Okay, ID is number of interchanges in the 6 mile, divide by 6. Okay, so this one already calculated, and this one will give you the total for the weaving. So this one, the other part is optional lane changes for the weaving. Okay, for the non-weaving people, first of all we'll calculate their intensity, INW, which is called as the intensity for non-weaving. So short length, interchange density, flow rate of non-weaving people. So if you have the one-sided weaving, okay, then the flow rate will be non-weaving will be ramp to ramp and freeway to freeway. If you have two-sided weaving, then this flow rate will be ramp to freeway and freeway to ramp. Okay, things will reverse for two-sided. So once you know I and W, then you can calculate the lane changes for non-weaving people using one of these three equations. So they depend upon the value of I and W. The selection of the equation depends upon the value of I and W. That's why we're calculating it. Okay, so now one thing, if Yes, let's say your uh, INW is this value, less than 1300, less than equal to 1300. So you are here. So you will use equation 1, this way equation 5.56. Okay, this is the default. But after using equation 1, you still need to use this equation as well and compare between them. You will take always the higher value. Okay, if your INW is less than 1300 or equal to, by default you should use equation 5.56. But after using this equation, you still have to use equation 5.57 and compare between them. Okay, and you will take the higher value. Okay, so with equation 5.56, there is an extra condition here. Okay, and once you calculated it, the non-weaving ones. Okay, so this one gives you for the weaving people, this one for the non-weaving people. The all will be when you add both of them. Okay, this is the equation to calculate the speed of the weaving people, weaving traffic. Okay, so you need the W value as well. Okay, W will be calculated from here. This equation will give you the speed for the non-weaving traffic. Okay, speed of weaving traffic, non-weaving traffic. Then you can calculate the total average speed for weaving plus non-weaving. This will give you the total density. Okay, once you have the total density, you can put it over here. So wherever we are using we mean total flow rate, and N means total number of lanes, including everything. Okay, let us look at an example. So pay attention, we will not be doing many examples here. And you can see there can be many changes in the geometry of the segment. Okay, so you need to pay attention so that you understand the concept. Okay, so we have a standard ramp weave segment with 3 lanes. Okay, so this one, 3 lanes here. Okay, and this one is a standard weave segment. If it was 4 lanes, then it will show 4 lanes on the freeway. Standard ramp is 1 auxiliary lane connecting ramp to ramp, and you have ramps on one side. Okay, the first thing I need to do is I need to convert these volumes, okay, to the flow rates. Okay, I need to convert the volume to the flow rates. Okay, passenger cars per hour, and all of them, I will consider all of them as flow rates. Like I will consider that the peak hour factor is already divided. Okay, you have seen in the previous examples for the merge and diverge segments, the flow rate is usually this, the volume divided by peak hour factor and FHV. Okay, this is how we calculate the flow rate. Here the peak hour factor is not given. Okay, they have used the term flow here, so I'm considering them, all of them are already divided by peak hour factor. Okay, so they are already divided by peak hour factor, so I will just divide it by the FHV here. Okay, I have a level terrain, so FHV is 1 divided by percentage of trucks, ET minus 1. Okay, this gives you FHV. So I need to find out ET, percentage of trucks, it's 10% here. Okay, so I will take it same for all the traffic. ET depends upon terrain. We have a level terrain. For level terrain, there's a table here for finding out the ET factor, this one. Okay, so for level terrain, the ET factor is 2. Okay, so give me the value of FHV here. I request all of you to pay attention and be active. Okay, yes, what is my FHV here? Okay, now I can calculate the flow rates for all of them. As I already mentioned, I'm assuming they already divided by peak hour factor, and that's why it's not given. Okay, so I'll just divide it by this thing. Okay, so main line volume means freeway to freeway. Okay, so this is freeway to freeway. Then if I calculate entering means ramp to freeway. Then I have exit. Exit means freeway to ramp. And then we have ramp to ramp. Okay, how much is this? Yes, give me these values. Okay. Good, and the last one. Okay, so we have these values and all of them are in passenger cars per hour, keep in mind. So we can move on now. First thing I will check if this is a weaving segment or not. Okay, it's a standard weave segment which has standard means this, so it has two weaving lanes. Okay, two weaving lanes. So I need to calculate the VR here. Okay, VR is the weaving volume, freeway to ramp, ramp to freeway upon total. So it will be 972 plus 811 divided by total 5167 plus 972 plus 811 plus 194. Okay, how much is this? Okay, now we can use this figure over here. 125 will be somewhere here and then you can find out, but as you can see this will not be accurate. Okay, I will be assuming value. So let us use the equation. Okay, so VR is 0.25 and NWL is 2. Okay, how much is this? Okay, so if the given length is less than this, then we can consider the weaving segment. Okay, the given length is, as you can see, 1850. Okay, so this is less than the Lmax, so this is a weaving segment. So I can move on with the rest of the calculation. First thing I will do is I will calculate the minimum lane changes. Okay, so lane changes for to go from ramp to freeway is 1 standard segment, ramp to freeway is 1, and freeway to ramp is also 1. So both of these are 1 1. Okay, so basically you're just adding the ramp to freeway and freeway to ramp flow rates. Okay, so minimum will be SE minimum. Okay, ramp to freeway, freeway to ramp, these two. So just for record, 972 into 1 plus 811 into 1. Okay, so how much is this? Okay, then we will perform the capacity check. Okay, so I need the capacity of the basic freeway segment. Okay, which was 2200 plus 10 into S minus 50. Okay, so this will, we already seen this equation earlier. This will give you basic capacity of basic freeway segment under real conditions. How much is this? Free flow speed is given. It's given as 65. Okay, free flow speed is 65. Okay, so now we can use this equation. Okay, so CIWL was 2350. And this is 1850. Okay, how much is this? Okay, so now I will multiply with the number of lanes I have. Okay, so we are considering a basic segment. This one you can see 1, 2, 3, 4 lanes. Okay, so we have 2105 multiplied by 4 to get the total. Okay, so how much is that? Okay, I need to check that this value should be less than this ratio. Okay, so how much is this ratio? Because I have two weaving lanes, so this one. I have another check if I had three weaving lanes. So how much is this? Okay, so my capacity is less than this value, so I can proceed with this one. Okay, and the first thing I will do is I will check if my total flow is less than, so this is my final capacity. Okay, if this value was more than 9600, I will take 9600 as my final capacity. So now I have to check if my total flow is less than this value or not. Okay, total flow means everything included. So which is basically all the volumes. I did it here, this one. So this value should be less than the capacity 8420. Is it less or not? Okay, so we are on the safe side. If this one was higher, we would have set the level of service as F and we would have terminated the analysis. But now we can move on. So we'll calculate the number of weaving lane changes for the weaving people. This one already calculated. Now you calculate the rest of the things. So SEW, I need the minimum, which was 1783 plus 0.3950 minus 300 into, I have 4 lanes, 4 square, interchange density is given 0.9 interchanges. Okay, 0.39 is multiplied by all of it. So how much is that? Okay, the next thing is for non-weaving people. For non-weaving people, I have to calculate the I and W value first. So I need the non-weaving volume here, which is 5167 freeway to freeway plus 194, which is ramp to ramp, divide by 10,000. Okay, this is 10,000. Let me remove it. 10,000. Okay, 4 zeros. So how much is this? Okay, so we are here in this range. So I told you when you are in this range, you have to calculate both values and pick the higher one. Okay, so I will calculate from the first one. Okay, this one and the other one as well. Yes, give me both these values. Okay, and the other one. Okay, so as I said, we will pick the higher one. We will pick this one. Okay, so now we'll calculate the total lane changes using this one. Okay, so for the weaving people, the lane changes were 2190. Now we are calculating. So 2190 plus 2884.3. How much is this? Okay, so I am back and okay, so we calculated the all lane changes. Moving on, we will calculate W now. Okay, so W is all lane changes 5074.3 divided by the short length to the power 0.789. Okay, how much is W? Okay, then how much is the speed for the weaving people? Yes, how much is speed for the weaving people? Okay, and then this is for the non-weaving. So how much is this? Okay, so we have the speed for the weaving and non-weaving. We can calculate the density and then the speed and then the density. So this will give you the average total average speed. Okay, so weaving and non-weaving, which is basically total. Total is I wrote it here somewhere. Yeah, 8420 total volume weaving plus non-weaving divided by weaving volume upon weaving speed. Did I calculate weaving volume somewhere? I don't know. Okay, weaving volume. I believe I have it here somewhere. Yeah, 1783. So this is my weaving divided by the weaving speed, which is 55.7, plus non-weaving volume, which is total minus weaving divided by non-weaving speed, which is this one. Okay, how much is that? Okay, then for the density, I need the total volume 420 divided by number of lanes 4 divided by the speed. How much is that? Okay, if this is the density, then the level of service according to this is E. 35.8 is here. Okay, so level of service is E. Anyone has any questions? Are there any questions? Okay, I'm afraid the other ones are not paying attention. These problems are very typical. So if you are feeling that, okay, we will look at the recording and understand everything, it will not happen. I can assure you that. Okay, so it's up to you. So I have another one here. Okay, I will explain. You can do it. You will do it at your own time. Okay, the things which are given mentioned here. Okay, the flow. This one is freeway to freeway. This one is ramp to freeway. This one is freeway to ramp, and this one is ramp to ramp. All of them are passenger cars per hour. So you don't need these factors here. They are already converted. Okay, these values are already converted. So you will start with after the flow rate, whatever we did after the flow rate. Okay, so my freeway is going like this. Okay, my freeway is going like this. So this is on ramp and this is off ramp, and you can see off ramp has 2 lanes here. Okay, so if I am looking for lane changes to go from ramp to freeway, minimum lane changes, if I'm coming from the ramp going to freeway, I need only one lane change. Okay, lane change for ramp to freeway, yes, is 1. If I am coming from the freeway going to the ramp, okay, I need like if I'm on this lane, I can make the can go towards the ramp with 0 lane changes. Okay, so I don't need any lane changes to go from freeway to ramp. Okay, then if you look at how many weaving lanes you have, this one I can make one lane change and go to the freeway. This one I can make 0 lane change and go to the ramp. Okay, and this one I can make one lane change and go to the ramp. Okay, so I have 3 weaving lanes here. Okay, total number of lanes 1 2 3 lanes. Okay, I believe the rest of the things are part of the calculations. Free flow speed is given, so try this one. Okay, interchange density is also given, so try this one, and if you face any problems you can let us know, especially during the class, so others can also benefit. Okay, this is the short length. Okay, so good luck with that. So next time we will have the exam, and after the exam we will inshallah finish this topic. Okay, any questions, any queries?